Alright, so now we're going to look at solving equations using the distributive property. To introduce the idea of the distributive property, I'm going to give you guys this rectangle, and then I want to know what is the area of this rectangle. So remember, if you think about area is length times width. Now you can solve this problem any way you want. I'm going to give you a little bit of time to think about it. Alright, so everybody has thought about it. There's two ways that you could actually find the area of this rectangle. You could do it by looking at each rectangle separately. You could do 3 times 7, get one part, and then add the area of the second rectangle, this one over here, which is 3 times 5. So if we do this, we get 3 times 7 is 21, plus the area of the other rectangle, which is 15, 3 times 5. And you get that the area of the whole rectangle is 36. Now, did anybody do it a different way? Another thing you could do is you could say, hey, that side of the rectangle is 7 and 5, which means 7 plus 5 is the whole dimension. So you could simply say that the area is 3 times 5 plus 7. Now, let's check to see if this is the same thing. 3 times 5 plus 7 is 3 times 12, which is 36. So now we can see that these two statements are exactly the same thing. They both equal 36. This is a good example of what the distributive property is like. Now in math we like to have big definitions for everything, so the distributive property actually has a nice little definition for it. The distributive property is what has made that statement earlier on the previous slide true. It says that 3 times 5 plus 7 is the same as 3 times 5 plus 3 times 7. So you can see I like to use arrows. We did 3 times 5, and then we did 3 times 7. That ended up with 15 and 21, which got us our answer of 36 again. Now the distributive property using symbols in math looks like this. A times B plus C is the same as saying A times B plus A times C. Now this distributive property is awesome because it's true all the time. As long as you distribute what's outside the parentheses into everything inside the parentheses, you will always get a correct answer. Now, is the distributive property true even if you don't have any numbers? Well, of course it is. So let's use the distributive property to rewrite this. This is 2 times the quantity x minus 4. If we use the distributive property, we can see that it is 2 times x and 2 times negative 4, which is negative 8. So 2x minus 8 is the same as 2 times the quantity x minus 4. Let's look at another example. Say you had a negative sign, and then inside the parentheses you had 2x plus 3. In a previous video, we talked about that negative sign, and we said that really that was like saying a negative 1. So now you can see that it's negative 1 times that quantity. So if we use the distributive property, we do negative 1 times 2x. That's just negative 2x. Then we do negative 1 times positive 3, which is negative 3. So negative 2x minus 3 is the same as that amount we had above. The trickiest part of the distributive property is remembering to distribute to everything. A lot of the times it's easy to forget about this number back here and just distribute to the first term. We're going to use this distributive property to help us solve an equation. So here's the equation we're going to solve. I know it's an equation because it has an equal sign in the middle of it. We're going to need to use the distributive property before we can think about our do and undo chart. So let's draw our line down the equal sign, and then let's apply the distributive property. 3 is what's outside the parentheses, so I'm going to distribute that 3 to both terms inside the parentheses. 3 times x is 3x. 3 times 2 is positive 6. So now we can see, hey, that looks just like the equations that we've been doing for the past couple of videos. We can do our do and undo chart. If you don't want to do the do and undo chart, that's okay. I'm going to draw one just this first time so we can remember what it looks like. If we read our problem, it says 3x. That means 3 times x plus 6. So there's my do column. Undo, the opposite of adding 6 is subtracting 6. The opposite of timesing by 3 is dividing by 3. So I'm going to use this undo chart to help me solve. First step, minus 6. Remember with your equation to keep it balanced on both sides. Becomes 0, and I'm left with 3x equals 12 minus 6, which is 6. Alright, last step we need to do on our do and undo chart is divide by 3. Both sides get divided by 3. These become 1, and x equals 6 divided by 3, which is 2. So we just solved an equation that used the distributive property. Good job. Alright, so this is a really big problem. It looks like we have lots of different terms over there, and we have parentheses that we need to deal with. But if we take this step by step and use the things we've learned in these past videos, we'll be able to solve it. So the first thing I'm going to do is draw my line. I'm going to draw a long line because I bet I have a lot of steps this time. Now, in the middle of your problem, you have a distributive problem because you have some parentheses. So let's go ahead and take care of that first. Now in front of this we have a plus 7, a positive 7, which means that's what gets distributed. The x has nothing over there with it, and neither does the negative 4. There aren't any parentheses, so we're going to keep those like they are. So x will stay x. Distribute your 7, and you get 7x minus 7, and then the minus 4 stays just like it was before. Now, if you remember the previous video, we talked about like terms, combining like terms. Do you see any here? We have 1x and we have 7x's, and that is not a very efficient way to write that. Let's combine these and say that we have 8x's. Okay, and on the other side, it looks like we have negative 7 and negative 4. Again, not very efficient. Let's combine them. Negative 7 and negative 4 is negative 11. Now we have a regular equation that we know how to solve. If you want to make a do and undo chart at this point, you can. If not, you can just remember that we're isolating x, so we have to get rid of everything that is not x. So let's get rid of the negative 11 first. I'm going to add 11 to both sides. So these become 0, and we're left with 8x equals 24. Now again, we're isolating x, so I see that I need to undo that 8. So we're going to divide both sides by 8. And our final answer is going to be x equals 3, because 24 divided by 8 is 3. So again, look at all this awesomeness we just did. We started out with a problem that needed us to distribute, then combine like terms, and then solve. I've given us another big problem here, but we can do it using these tools that we've discovered over the past couple of videos. The first tool we need to use is the distributive property. We need to get rid of those parentheses. With the first set of parentheses, there's just a negative sign in front. So remember, that's just like saying negative 1 times all of that. So that's what we need to distribute in this first set of parentheses. So we're going to end up with negative 1 times 1, which is negative 1. Negative 1 times 7x, which is negative 7x, or minus 7x. Now if we look at the front of this second parentheses, there's a minus 6 in front of it. So let's distribute the whole thing. It's negative 6. This will save us some work later on. So negative 6 times negative 7 is positive 42. And negative 6 times negative x is positive 6x. Now on our other side, there wasn't anything to do, so that's going to stay like it is. Alright, now, looks like we have a lot of stuff going on there. Remember our combined like terms? Let's start with the x's. Negative 7x's plus 6x's. Negative 7 plus 6 is negative 1, so I can say negative 1x is what I have in the x place. And then negative 1 plus 42 leaves me with 41. Now, just because everything is over on the right-hand side doesn't mean we can't use the same steps we've been doing. Our do and undo. We need to undo all the things that aren't x. So let's undo that plus 41 first. To undo plus 41, we would minus 41. Alright, so negative 1x stays by itself over here because these cancel each other out and make 0. And then we end up with 36 minus 41. So that's going to give us negative 5. Now it looks like we only have one thing left to do. Let's divide by negative 1 on both sides. And we're going to end up with negative 5 over negative 1, which is just 5. So our final answer is x equals 5. Alright, let's try just one more because I think we're getting pretty good at this. This equation is another one that's going to require us to do a lot of steps, but if we start out with that distributive property, it shouldn't be too bad. So let's draw our line down the equal sign, and it looks like we have a negative 3, a minus 3 in front of the first parentheses. So that means we're going to distribute a negative 3 to both things inside the parentheses. Well, negative 3 times 4 is negative 12, so you have negative 12x. Negative 3 times positive 3 is negative 9. So that takes care of the first set of parentheses. With the second set of parentheses, looks like we have a positive 4 to distribute, so that's just like distributing 4. 4 times 6 is 24, so we have a positive 24x. 4 times 1 is positive 4, so we have a positive 4. Now, it's still pretty messy over there on that right-hand side of the, left-hand side of the equation, and we want to combine like terms. So let's start with the x's. I have negative 12x plus 24x. Well, negative 12 of something plus 24 of something leaves me with 12 of something. Now I have the number negative 9 and the number 4, so negative 9 plus 4 is negative 5. Alright, now it's just our do and undo steps. So this should start being really familiar to you guys. We should be able to start getting pretty quick at it. We need to undo everything that's not x. So let's undo minus 5. Minus 5 plus 5 undoes, becomes 0, and we're left with 12x on this side, equals 43 plus 5, which is 48. Alright, one last step to do. We have to undo 12, and that's 12 times x, so we're going to undo by dividing both sides by 12. 12 over 12 becomes 1, so we can cancel those out. We're left with x equals 48 divided by 12, which in this case is 4. So what we looked at in this video is we looked at adding the distributive property into solving equations. The distributive property says if you have a number in front of the parentheses, then you would multiply that number by everything inside of the parentheses in order to make it into a form that you can solve.